Hello, here we are in the MakerLab today, and we are going to have a quick overview of the 3D printers that are in our armada. So first and foremost, we actually just received this one yesterday. This is the Cube Pro Duo, and this was gifted to us by a former student. A little information about this. The company that manufactures it is 3D Systems, a US company. The print technology is, they call it FFF, and that's fused filament fabrication. Some of the selling points: it's the largest in class build platform, and that's a 9.5 by 10.6 by 9 inch cube build envelope. It has ultra high resolution. It has 2 extruder heads, which we will talk about for a variety of different materials. The cost of this is about $2,000 to $3,000, depending on a few of the bells and whistles you want to include with it. The material that it runs is a 1.75 millimeter filament, and our student generously gave us a whole variety of materials, including some PLA, ABS, nylon, and rinse away support material. The software that it uses is a free downloadable software from 3D Systems that is fairly intuitive. Precision is 70 microns for high resolution, 200 microns for standard, and 300 microns for a draft resolution. Cost for student prints is $1 per cubic inch, and some of its strengths are: it's good for a mid-range price point, excellent for large, high-quality parts. Next, we have the first generation XYZ Davinci Mini. This is manufactured by XYZ Printing, and that is a Taiwanese electronics conglomerate company that has really been pushing their 3D printers in the last couple of years. Again, this uses an FFF, fused filament fabrication. You'll also heard that referred to as FDM, fused deposition modeling. It's lightweight, it's transportable, it's fast, it has inexpensive prints. This printer costs a mere $220. The print bed is about a 5.9 by 5.9 by 5.9, so not quite a 6 by 6 by 6 print envelope. It too runs off 1.75 millimeter filament. It does take proprietary cartridges. This is an example of one of the cartridges. They do include PLA, premium metallic PLA, ABS, and PETG. We run PLA on most of our desktop printers for a few reasons. It is a biodegradable material. It is polylactic acid. It's a corn-based material. It prints at one of the lower melting rates, and so that temperature-wise, that's to our advantage and for speed. And also, it does not create noxious vapors. Very important. Whereas ABS and some of the other materials can create some detrimental vapors. Moving right along, another one of our desktop printers. This is the Anycubic I3 Mega. It's manufactured by Anycubic. The print technology, again, is an FDM, fused deposition modeling. One of the strong selling points of this one is it's an open source material and slicer software printer. It's lightweight, it's transferable, it's fast, and it does provide inexpensive prints. Cost on this printer is $250. Has a bit bigger print bed. It's 8 by 8 by 7. It too uses a 1.75 millimeter filament. Nice thing about this is it will print a variety of different brands and types of material. For example, we have some, this is a wooden PLA. We have a Prusa metallic black. You can see it back in here. Beautiful material. So you can go on to Matter Hackers or any number of software sites and purchase, or excuse me, hardware 3D printer sites and purchase inexpensive material. It also has a sensor that indicates when we've run out of material or when it's clogged. So that's kind of a nice value added for a desktop printer. For software, the slicer softwares, it will run off any variety of software. So that's a really positive piece that we use Cura, but any number of other softwares can be used. And so you have a wide variety of settings and options that you can play with on this one, whereas a lot of the other printers using their proprietary software and materials, you're much more limited in the options that you can play with. So this is a really great educational tool for students to use and to have much greater control. There's also a much larger degree of variables, which can be detrimental too. Something to keep in mind. Precision, it does claim to go down to 50 microns. That's being very optimistic, I think, but it is very high resolution. This too it's $1 minimum for a print, and it's 10 cents a gram for student prints. So very, very affordable. It's good for fast, cheap prints. Again, it's open source, so that's really one of its attributes. It has a heated bed, so this one can actually be printed on without using any type of tape or glue, although a tape can be used, a double-sided tape, if necessary. We also run it using an SD card, which is nice, so it can be moved around. We set up the print in the software on our desktop computers and then have that option of the SD card so that when our print computers go down at night into deep freeze, the machine doesn't shut down. So those are our three desktop printers here in the MakerLab, and next I'm going to show you the printers in the printer plotter room, room 4533.